my relative Fremont Fallows if he would give us a opening with Czechia, and then we'll get started with that. Fremont.
Oh, Tunkashila, Wakantraka, Eake, Ampetuya Kokele Ampetuki Wapila, Hechalo, Tunkashila. Na kele Ampetuki Wana, Ominichole Uki Octekele, Yakuku Imungla Kokta Hechi Tunkashila, Le Ampetuki, Woyukchana, Wokachne, Waste, Unichila Pelot Tunkashila, Hechelukija Tukata Kele. La kota tuktektel oyank kukile na trokata ke tagni shicha ki ponchipsne tayan oyank ke na tayan waste chimpelo tronkashela na kele apeto ke tronkashela leltona omanichu hiu kele apeto ke tronkashela wo ke na wichozane waste onichi la pelo tronkashela na le apeto kele na onshia hoalo o mitake oyasi.
Oh, Wopula. We'll count this down. Thank you for that. At this time, we want to invite Mr. Bill Means to come forward to give us opening remarks. Bill, would you come forward? Bill, longtime leader of our Oyate, many, many years of service to our people. And we're grateful for Bill and his presence here today. And if Bill would give us his thoughts on getting our meeting started today. So with that, please welcome Mr. Bill Means.
Amedak Ripi en particular chante mawase na prechita lo ihani washte. Ladies and gentlemen, the honor to be here. First of all, I thank the Nahashi of over by White River. We thank him for his beautiful prayer and also the drum communicates for us to Kakashila. As men, women, we're just communicators. I'm not a medicine man or a spiritual man of all that. I just learned from those type of people, and I'm still learning all the time. But it sounds really good to hear the content and the presentations regarding our future in this world, especially where it regards to climate change. They used to call it global warming, and whatever the term that you use, the more that you know about this, the more that you realize that we're in danger of destroying the earth, or not the earth, because we're only men. We can only destroy the ability to live on the earth. Mother Earth is too strong. Mother Earth will cleanse herself, as you can see in the extreme weather variations that we're all experiencing. And if this young man will quit interrupting me, we'll get going. I know he's a sound man. He's got about 10, 15 mics to keep track of. Some from Pine Ridge, some from Rosebud, some from the internet, some from various other places, all over the world and various other places. So he has a big job to do, and I appreciate him making this recording for future generations, because that's what we do this work for. And I think all the tribes that are represented here, sometimes those that need to be here aren't here, but nevertheless we can show them the tapes. We could show them some various experiences that we've all had here, and pass this information on, because it's so vital to those future generations. So some of the things I heard, for example, we're all involved in various aspects of survival, including buffalo. Our teachers, our elders have told us for many years that we can learn the future from our animals, especially the buffalo. I have the honor of working with our tribe, the Oglala, and various other tribes, including Lower Brule, Rosebud, uh, Fort Thompson, Cheyenne River, all these people that are reviving the relatives of buffalo. And it's been a job to educate even our own people, because even in the thinking and the education of our youth, we don't learn about buffalo. We learn about cows. And so education itself is learning a lesson that we need to learn from our indigenous peoples, because these are the teachers. These are the survivors of the environmental crisis that has been brought to us by the modern world. And so we appreciate this information, the willingness for tribes to get together, pass this very important teaching, the future of our people, the future generations. So we thank Phil, we thank all those sponsors that have come here to lend their support, but also the tribes. There's 500 and some readily recognized tribes just in this country. So we have our friends, indigenous people. There's 80 million indigenous people in this world. And so we're not an insignificant minority that a lot of people would have us believe. We are a growing visibility in the world as teachers, because people are beginning to depend on us, because we live and have survived with nature for all these generations. And so we have something to teach the world. I found this out while I've been working at United Nations. They depend on indigenous people to help tell the future what's coming. Because we know that because we can communicate with the natural world. We don't have to read everything out of a book because the educational world and the white thinkers of this world, they have an idea that if something is written down in black and white, it inherently has more truth to it. And so our people believe in the oral history of communication. And so we believe that we learn more by passing that information from generation to generation orally and through our ceremonial ways. And this is how we have learned to live with Mother Earth. And so I feel really good about this conference. It's about time. We've had a lot of conferences on various issues. We all went through this pandemic, and we learned a lot of lessons from that, and we lost a lot of people from that. And so a lot of our knowledge keepers are no longer with us. But through conferences like this, we keep the circulation of information going. And so I thank all of you, and you keep the spirit of information going because that's how we're going to be able to educate these young people. And, I know the way that my grandson, whenever I get stuck on a computer, I call him. He's only 7 years old, but he knows a computer. So when I get stuck, I call him up and he gets me back on track. And that's pretty good to see because that means that we have the ability to communicate that we didn't have before. And I see the future many times through his eyes, his questions, and the things that he tells me and asks about. So the future is in good hands. I see some young people, presenters from all walks of life. Some are very well educated. Some come from a traditional perspective. You heard from some of our most powerful spiritual leaders yesterday, and they gave you a glimpse into the future. And so we still have those people to learn from, but the future looks bright. I feel very confident in the next generation of our people because they're learning things that we didn't have access to or we didn't learn in our lifetime. So the information is expanding. The effects of this environmental crisis we're in are becoming more clear every day. And people are beginning to think about when they look at their grandchildren, what are we going to leave them? What do they have in their future? What does survival look like in their world? And sometimes we get worried, but on the other hand, I feel very confident in these young people. You'll meet some of them today in the presentations. So we thank again Phil and the uh, Treaty Council from Rosebud, Sichangus, for bringing us together, taking the lead, because a lot of us are interested in this, but sometimes we got to have a little shake. We got to shake the chair, shake the building, shake the teepee in order to wake our people up sometimes. So I thank all of you for coming. I look forward to continuing the flow of information from this conference. Take some notes, take the information back with you. And it's wonderful to see so many people have the concern and the idea of indigenous peoples uh, leading in this effort to survive the natural world, to make a place in this world for natural thinking for the future generations. Oheche tulo mitako ye oyasi. Ahu.
Thank you, Mr. Means, for that well-spoken open remark for us to get started today. We will have a morning session of the Western Science approach to what's happening on climate change in our region, and we're all happy that we have the ability and capability to bring in speakers who've been working with us on climate change and the tribes. So this morning we will have two presenters going to give us their take, their understanding, and their research on climate change. We'll also have a presentation on some of the social science aspects of climate change impacts. And so we're looking forward to a good morning. Um, our first presenter this morning will join us from Zoom. He's going to be talking about projected changes in climate and water availability in the northern Great Plains. So we heard water again as an important part of our definition of climate change from a Lakota perspective, Lakota language. So he's a research scientist at the University of Colorado Boulder. His name is Imtiaz Rangwala. He's also the lead scientist at the North Central Climate Adaptation Science Center. He has extensive experience in the development and communication of useful and usable future climate change scenarios, for natural resource management in the Intermountain West and the Great Plains region. So he's a friend of mine. He's a colleague of mine, and we're so grateful that he's here with us today by Zoom. So with that, MTIs, are you there? And we're ready to go here.
Thank you, James. Can you hear me okay?
Okay. Yes.
Okay.
Fire away.
Okay. I'm going to go ahead and share my screen. Let's see if that works. Can you see my screen?
Looks good. Looks good, MTIs.
Great. Well, thank you again, James, Bill, and thank you for the opportunity to present in this conference. It's really a great honor to be here. Before I start, I want to offer my respects to the elders and the distinguished guests in the room. As James mentioned, I'm from Boulder. Just speaking from Boulder right now. I work in Boulder, which are traditional lands of the Arapaho, Cheyenne, and the Ute people, among other indigenous people who have deep relationships with these lands. So I'm going to talk about what we can expect in terms of changing climate and water availability in the northern Great Plains, and I'm hoping that my presentation will complement what Doug Clark presented yesterday and what Laura Edwards was sitting right after me. So I'm going to look at what's coming, but also kind of give an indication of what's actually happening. But before I do that, I would like to briefly touch on this topic of global climate crisis, and different speakers have addressed this, and in terms of how critical this issue is for us and how urgent this is for humanity. So, giving you a brief overview, one of the main causes of this crisis comes from the rapid increases of greenhouse gases in our atmosphere. And this graph on the left basically shows greenhouse gas concentrations and the primary greenhouse gas, which is CO2, carbon dioxide, going back 2,000 years. So if you see for the last 2,000 years, we've been pretty stable, close to 270 parts per million. And suddenly, the beginning of 19th century, we really started to emit rapidly and increase this concentration rapidly in our atmosphere, especially since 1950. There's been a sharp increase in the greenhouse gas. So, human activities have really rapidly increased this concentration and changed the chemistry of our atmosphere. And one thing with CO2 is once you put in the atmosphere, it just stays for hundreds to thousands of years, and that's the big concern. We cannot remove it out of our system very quickly. So right now, our concentration is moving between 415 to 420 parts per million. That's a very, very large number. Um, and the concern here is that if you look on this figure on the right, is that as you add more of these greenhouse gases in the atmosphere, it traps more of this energy that would otherwise escape to the space. And so what we are doing is we are trapping more of the heat in our climate system. And that is not trivial. And so if you look at the amount of heat we have been accumulating, it's a lot of heat. So since 1970, we have accumulated close to 5 billion of the Hiroshima atomic bombs worth of heat in our system, in our climate system. So 5 billion, the B, billion with the B. And I remember Doug Clark mentioning in his talk that last year, a lot of heat got accumulated in our ocean. The heat content of our ocean uh, went up by a significant amount, and so again, the number here is that our ocean absorbed close to 7 atomic bombs worth of heat every second last year. And ocean is actually absorbing much of the heat that is trapped by the Earth system. It covers 70% of the surface area of the planet, and actually drives much of our climate and weather, and that's why ocean is important. So again, just making the point that a lot of heat is getting trapped in our climate system, and that drives changes in our climate and extreme weather across all regions on the planet. Just another graph making the same point about changes in the heat content of the ocean, and this is just I think one of the most important metric out there to look for climate change, in my opinion. And basically, it just shows a very clear trend that the ocean is heating, and more rapidly in recent times. It's a great concern for us, and clear evidence that climate is changing. So, looking into the future, what tools do we have to look into the future? And one of the tools that we tap into quite a bit are what we call our global climate models. More and more, we are calling them the Earth system models. And so these are very sophisticated models. There are different modeling centers across the globe, more than 20, that develop these models, and we take information from all of these models and bring them together to kind of make sense of what our future could look like. And we are developing more and more confidence in the information coming out of these models. And the projections coming out of these models, we don't use the word predictions, we say projection scenarios of climate change in the future. And that's what comes out of these models at global to regional scales. And for the last several decades, we've been looking at the information coming out of these models, and they've been pretty consistent, and that gives us confidence in much of what the future climate trends could look like. So I mentioned about the climate change that's already occurred, and if you look at this graphic here, it's a little light here, but what it shows is global temperature change since the 1950, and the line in the blue basically shows how much we have warmed. So we have warmed our planet close to 1.1 degrees Celsius, so it's just a little over 2 degrees Fahrenheit. So that's global. And the other colored lines show where we can go based on these climate models I was just talking about. And the global community has said, uh, to avoid effects of very dangerous climate change, we should keep the global temperature below 1.5 degrees Celsius. Um, there before that we have been thinking let's keep the climate under 2 degrees Celsius, but I think the community has said 2 degrees not that safe. But there are very few scenarios that of emissions that take us that keep us below 2 degrees or 1.5 degrees. Only one scenario of our future, how we, our future um, emissions, would look like, and that could keep us under 1.5. The story, I mean, so the point I want to make is we have to work very hard to keep our emissions uh, very low to meet these targets. And anything about 2 degrees, we get into very dangerous territory. Um, and you know, no matter which route we take, the medium emissions or low emissions, we will be impacted by effects of climate change. And the issues of food and water security and habitat loss and ecosystem transformation will be some of the major challenges caused by climate crisis. And so what needs to happen, and two things need to happen. We need to do mitigation, which is decarbonize our economic and industrial system. Um, and we need to adapt to the climate that has already changed and is expected to change. And that adaptation is really increasing the resiliency at our local, regional, and national scales, and even global scales. And much of my work at the North Central Climate Adaptation Science Center focuses on, the issue of helping community better adapt to a changing climate and reduce their vulnerability in many sectors. And so in that regard, I'm going to just focus my talk on one thing we have to do is understand how climate is going to change and what impacts can ensue and develop solutions around increasing resiliency. So now I'll move to more regional scale to the Northern Great Plains and just talk about observed climate change in recent decades. This again complement what Doug talked about yesterday and what Laura will get into, and also relate that to how what the models have been talking about, changes that could come in the next few decades, and are they consistent with each other, what we're observing and what we are actually projecting. And also, I just wanted to mention a lot of this information comes out of that I want to share comes out of this project that we have recently finished called the Grassland Synthesis Project at the North Central CAS. And there was tribal input into this project. So starting with the climate of the northern grasslands, and this is a lot of information here. Don't worry about just these graphics. Maybe if you want to look at it, you can look at the northern mixed grass prairie where I'm showing the climatology of the region, which is minimum and maximum temperatures in these orange and red lines, and the bars show how much precipitation you get. But the point I want to make is this region has an interior location, interior continental location, which means that there's a large variability across the year in terms of experiencing cold winters and warm summers. And because this land is open to the free movement of air masses from the Arctic as well as from the tropics, this can create sudden change in weather, and it's prone to high winds. And so extreme weather can really emerge very, very quickly. It's sensitive to these large-scale atmospheric circulation patterns. So more than any other place in the country, it's, again, very sensitive to experiencing wet and dry extremes. The flooding and droughts are much more common in this region. And so the variability is really the name of the game in this region. And historically, you know, livelihoods have been adapting to this large variability and expected that with a changing climate, this is just going to increase the wet and the dry extremes. And I'm going to talk about that a little bit. Um, so much of the moisture that comes in this region come between April and October. More than 50% of the annual precipitation is actually between April and July. Those are very crucial months. If you miss the precipitation during those months, it's really tricky in terms of water availability then for the rest of the year. So I'll get into now the changes that we are seeing and expected to see. This is showing temperature change, and we're looking at last 30 years and compared to much of the last century. And what we find that, and what I'm showing you is changes across the whole year and different seasons. And overall, we see that for the northern plains, that the annual temperatures have increased by 1 to 2 degrees Fahrenheit, with winter warming at the highest rate, and especially in the very north. So in the Dakotas and Montana, we see that winter has warmed by more than 3 degrees Fahrenheit. So that's the season that's warming the most. And on the other side, summer has experienced the least amount of warming. And in fact, if you look at much of the eastern plains here, show little to no warming. And I'll explain why that's happening. So when you look at precipitation, that kind of explains why we're seeing less of that warming in summer. But if you just look at precipitation, we're seeing actually there's an increase in precipitation across all seasons, and particularly on the eastern part of this domain here. And in some regions, such as the South Dakota region, increases has been as much as 10 to 20% in recent times. So climate change, if you look at projections, they kind of suggest that the region will see increases in precipitation, but we have seen a whole lot of increase, and this is an expectation that some of it is just driven by the natural variation in climate. There's another graphic kind of making the same point. This is looking at station-based data, and I'm just looking at a slightly bigger region across the West. So this graphic here on the left just shows either the annual trends in precipitation going up or down, and the blue shows increases while the red shows decreases. So just comparing the northern plains region with the rest of the West, we kind of see that we are in the sweet spot where we're seeing actually an increases in precipitation, more or less. And on the right, there is the graphic basically points to how often are we seeing very long dry periods. And here again, we find that the northern plains is in the sweet spot where it sees less of long-lasting drought conditions as in contrast with much of the West. So and that's one of the points I want to make in my presentation today is that the northern plains may be experiencing climate change differently from the rest of the West, where the rest of the West is maybe experiencing much more dry conditions and trends towards more heating and drying relative to the northern plains. And that how does that affect opportunities for future livelihoods and challenges associated with where people may want to move when climate extremes increase and water availability becomes a challenge. Continuing with the precipitation piece and what you observed, this graphic shows, and comes out of a very recent paper, which basically saying that each time you're getting a precipitation event, it's more intense. So each event is bringing more amount of moisture. And that's all. And something, again, our models have been saying that future precipitation events will be more intense, and we are seeing that, uh, and and it's true for much of the northern plains. So if we put together the story of temperature and precipitation trends that we have seen in this region, with temperatures increasing but precipitation also increasing, we kind of can explain some of these trends and how very extreme hot days are changing and very extreme cold days are changing. So we are actually not seeing a major trend in uh, increases in extreme hot days in the region, as shown by the map on the left. So everything in the blue shows actually we're not seeing a decrease in extreme hot days. As again, you compare that to the rest of the West, it's a different story where they are seeing increases in extreme hot days, and it's really the precip story that I believe making the case of us not seeing very extreme hot days. We're still seeing them, but uh, the overall trend is towards decreases. But if you look at changes in extreme cold days, the story is different. You would note again, as I talked about, that winter is warming at the fastest rate, and that's kind of captured here, that we are seeing decreases in uh, very extreme cold days in much of the country, but the trend is smallest in the northern plains. And I see how how much more the numbers are decreasing in much of the West compared to the northern plains. So we are seeing fewer of these extreme cold days, but yeah, the magnitude is smaller than the rest of the Western country, U.S. Um, this graphic talks about snowfall. It's on the left, saying what are the changes in total snowfall across the country. The blue shows increases, and red shows decreases in snowfall. So um, for much of the northern plains, we're seeing an increasing signal. So again, the precipitation is increasing, and that is causing the total snowfall to go up. The figure on the right shows a different story. The right is talking about how much proportion of snow to the total precipitation are we seeing. So, and here we're seeing that as a proportion of total precipitation, we're seeing less snow coming in the region. So more rainfall and less snowfall are occurring. And again, that's something we expected from as the climate warms, we'll see more rain than snow. So what are the impacts on our ecosystems? And there's a couple graphics I want to show about that. Again, this is what we're actually observing. And the left graphic on the left talking about the changes in the length of our growing season. So for our northern plains, we see that the growing season has gone up anywhere from 10 to 20 days, increases in anywhere from 10 to 20 days a year or more. In something, again, our climate models have been projecting, and data I've been looking at has been gives anywhere from increases in 15 to more than 30 days of increases in the growing season length by 2050, and I think we're already seeing those numbers emerging in our data. The figure on the right, again, is a response to that increase in the growing season. Is how soon are we seeing the first leaf date in the year? And again, across much of the country, especially in the northern latitudes, we're seeing that it's earlier and earlier we're seeing the first leaf emerging. So anywhere from as early as 10 days or more. So by at least a couple of weeks, we're seeing in many of these regions that the greening up is happening. So again, clear indication that the climate is changing and hydrology and ecosystem are responding to that. I know Doug Clark mentioned about increased changes in or increases in the pollen season, and this one graphic on that, again pointing to similar to the growing season, anywhere from 2 to 3 weeks or more of increases in the time period or the length of the pollen season. And this is for the ragweed pollen. Okay, so getting to the projections, part of changes in temperature and precip and other climate features now. So these graphics are the information coming out of the climate models, and I'm looking at mid-century, so not late century. This is mid-century, and comparing it to the last century, and specifically the 1960 but to 1990 periods. And again, this is the information that we generated for the grassland synthesis project. And I'm going to show several plots from that report now, talking about the projections. So what we're seeing is the annual temperature, which has already increased by 1 to 2 degrees in the region. We expect that by 2050, they would increase by 5 to 6 degrees Fahrenheit. They're expected to increase by that amount. So much more warming is in the pipeline. And this is looking at a median emission scenario. And we find that by at least 2050, the emission scenarios are less relevant. So something like 5 to 6 degrees Fahrenheit, the confidence is pretty high that we may experience that kind of warming by 2050. And that's a lot of warming. Winter and spring are expected to see the largest increase. We will expect to see, more frequent and more intense heat spells, and we may see, less of the cold spells. And this whole risk of frost damage to vegetation is unclear, and it may not substantially change because it just is the function of how the growing season is changing and how the risk of cold spells are changing. So, and so we may actually see frost damage or maybe more frost damage in the future, again, depending on how different things play out. For precipitation, as I said, models have been suggesting more or less increases in annual precipitation, with largest increases in winter and springtime. Models have been suggesting, for the most part, decreases in precipitation in summer, but there is less agreement across models for summer and fall in terms of direction of change in precipitation. So there is less confidence and more research is needed in terms of understanding what can happen in summer. But if summer precipitation is expected to decrease, that creates large risk in terms of water availability and drought-related impacts. In terms of storms, there is high confidence that future storms will be more extreme, and I'm going to talk about that in a bit. Another thing that we're seeing and expected from the climate models are the increases in the thirst of the atmosphere. As you warm the atmosphere, it can hold more water, and something that Doug Plank mentioned yesterday, and that can actually drive more evaporation and transpiration out of the land, so more evapotranspiration from the land. And so the net available water on the land is really a function of how much precipitation we're getting into the system and how much we are losing water from evapotranspiration. And temperature has this effect on evapotranspiration, that warming increases the rate of water loss from the land. So what about the risk for aridification or desertification and drought in the northern plains compared to the rest of the western U.S. Um, what we see from much of modeling is that um, at least in the Great Plains, there is greater risk for chronic drought in the central and the southern plains, and that's again a function of less increase in precipitation and more warming is causing is leading um, or leading to these projections where we see more chronic um, and intense drought in much of the central and southern plains. The story is slightly different for the northern plains where we see this larger increase in precipitation that offsets um, the warming induced increases in aridity and evaporative loss of water. Um, However, we can see more seasonal aridification in the west, and I'm going to talk about that. That in the latter half of the growing season, we can actually see more severe, dry conditions than we have seen in the past, and we are seeing that even in the models. And I'm not showing that result, but even in the scenarios where we're seeing large increases in annual precipitation, that by the time we come to the summer, we're seeing more extreme dry conditions. So, we can actually see the climate change in a way where we are seeing both more greening, and more drying in the future, where, as the growing season increases and the earlier greening is happening in an atmosphere where there's more CO2 available and more CO2 promote more vegetation growth, among other things. Um, and so we can have the scenario in the future, and there's like medium confidence that we'll experience something like that. That we'll see more vegetation um, and more greening in the earlier part of our growing season, and the latter half of the growing season we actually can see greater drying. So just within a year, we can see these very extreme condition in terms of what the landscapes look like. And that could lead to interesting opportunities and challenges, including, how the wildfire risk may change in the region, where we may have a lot of biomass growing in spring, and if that stays in the summer, late summer and fall, and dries out, it can create um, some intense wildfire risks. We may also see increases in the risk of flash droughts. So even though the northern plains region can see more uh, precipitation coming in and maybe fewer days, uh, fewer consecutive dry days. Um, but because the atmosphere is extremely dry, when we have when we experience consecutive dry days in the future, or longer length of dry conditions, um, we can see drought emerge very, very quickly. And I'm showing here maps from the 2017, what you call the 2017 flash drought in the northern plains, as an example here. Um, and before we went into this drought, we were in a 10-year period of extreme wet conditions. So getting into this drought was a surprise for many people, because this was one of those NOAA billion-dollar disasters um, that occurred. And this drought happened very quickly and went away very quickly, but created a lot of impact. And so studies are showing that across the globe, droughts are developing much faster in recent decades. And I think that risk just goes up and up as a warmer and drier atmosphere is sitting on top of our land. Anytime we have long periods of dry conditions, we are in the risk of really getting into a drought very quickly, and that drought intensifying further if the precipitation does not come. On the other side of the story, there is high confidence that you know extreme precipitation uh, will will be more frequent, and especially this figure is talking about changes in extreme rainfall, so the warm season convective rainfall, where we expect that those in particular will intensify much more with warming. So anywhere from increases in 7 to 14% increase in the intensity of these rainfall for every degree Celsius warming, or about 2 degrees Fahrenheit warming. And with that, the risk of flooding is also expected to increase in the future. Um, and so regarding the winter storms, the story is kind of similar. We also expect that winter storms are expected to be much more stronger, which means stronger blizzards. In terms of snow itself, uh, I said that the warmer temperatures will lead to more of the precipitation falling as rain rather than snow, and and that would mean shallower snowpack, earlier snow melt, shorter amount of time snow is on the ground, and lesser overall area covered by snow. So just less snow overall is expected because of warming temperatures. Um, and in these winter storms, we have just less confident in terms of how winds will change. But we expect, just more extreme precipitation to occur in these storms. Um, Getting to other aspects of water availability and stream flow, I know is a big concern in the plains, and tribes often talk about water availability, water in the streams. So what we are seeing in terms of recent trends, and this is looking at the map of the whole Missouri Basin, uh, that looking at different parts of Missouri Basin, the story is different. So in the upper, uh, the upstream area of the basin, especially in the mountainous region of the basin, we are seeing actually a decrease in the flow. And also in the very southern part of the basin, we're seeing a decrease in the flow. This is the Platte River region. But in the eastern part of the basin, we are seeing an increase in annual runoff. And again, this is reflecting the increase in the precipitation that's happening in this region as opposed to these other regions. And the expectation is that will continue. So if you look at projections from these downscale hydrology models, what we see that, if you look at, here are the results from 31 models, and they kind of point to increases across much of the basin in annual runoff. And so anywhere you see green are increases, and brown are decreases. So this is, the big map is showing results from, of all models. And then here on the right, talking about we're just looking at 20% of the very wet models and 20% of the very dry models. And again, you see that, if you just pick specific scenarios, there are differences where you see much more increases if projections are wet versus um, in times in climate projections where you do not see as much increases in precipitation. In the future, you'll see decrease in runoff. But more than these mean changes in stream flow, um, it's the extreme events and large variability across years which will have greater influence on water availability in the region. Uh, and so year to year variability, we're already seeing that in the region with some large flow, extreme flow, and flooding in some years versus very little flow in other years. The Mississippi right now is record low. Right, you can walk across Mississippi in many parts of the country. Um, so yeah, so this very wet to very dry is something we'll have to deal with, the changing climate. I want to touch a little bit on the groundwater. I would imagine Sayed Haq is in the conference, and Mr. Haq knows more about these issues. We are seeing that, at least when you look at the Ogallala aquifer, much of the depletion has happened in the central and the southern plains, with much less in the northern plains. In fact, some regions have we've seen increases in the water levels in these regions, or no change. Um, but there's probably some good news for groundwater emerging from these models, which are showing that even though there is there may be a lot of disagreement across models, in the mean uh, results, if you just focus on the mean results, what they're showing is that at least in the northern plains, we see increased recharge of the groundwater, and so all these processes with increases in winter and spring precipitation, more of the precipitation falling as rain than snow, and even these increases in extreme precipitation events. All of these actually help with recharge of groundwater. And so at least these models are showing that um, by both mid-century and late century, we may see that at least the groundwater is recharged well. And of course, this is just the climate story. How humans are extracting and the water is the different part of the story, and that could determine, uh, the net level of groundwater in the region. So, will we change our livelihood practice to extract more water in the future? That's a big question. Um, I'll, you know, so there, uh, this figure talks about future changes in, wetlands and lakes in the region, and more recently, the large precipitation events have, kept the soil moisture very high levels, and a lot of runoff has happened in these wetlands and lakes. So they've been doing well, but uh, but projections show that warming and increased precipitation variability can actually lead to fewer of those storms in the future. So it's interesting to see, like, does the current trend hold in terms of this intense precipitation or increase in precipitation we've been getting, and how the net effect of warming versus change in precipitation will play out. Um, so, but there's the expectation that extreme events will keep water in these wetlands and ponds, but combined with these intense droughts in between, can compromise the water quality in these ponds and lakes. Um, just one slide on wildfire. We expect that the wildfire frequency and size to increase, and but and as I said earlier, because of the swing between very wet and very dry conditions, we can see high severity in these grasslands fire in the future. We're also seeing that, at least from the models, that the prescribed windows for doing fire may decrease. Um, on the positive note, how we graze our land can really alter fire characteristics and reduce risk. Um, so I talked a lot about different aspects of climate change, and something we do at North Central Climate Adaptation Science Center is to understand how these different climate change scenarios, what kind of impacts they will create, and that's not a trivial task. There's a lot of complexity in our climate system, in our ecological system, and there's uncertainty in terms of how climate will change, and there's also lack of understanding, uh, despite all we know in terms of how climate relates to ecology. So uh, uh, at North Central CAS, we collaborate with different experts to kind of better understand how climate change will occur and what impacts it will produce. And we kind of really follow this model of doing a participatory assessment of these things, bringing in experts from all walks of life around talking about a specific system or sector and impact to that, and also developing strategies and and exploring what actions will be robust for adaptation under those changing climate scenarios. Um, yeah, and so we really want to, one thing I want to say is really want to engage more and more with tribes to understand the important issues that concerns the tribe, and just in a participatory manner develop these strategies. Um, and I'm hoping people like James, Stephen, and Kinzer, who will speak later today, um, uh, we rely on them and be deeply involved with them to kind of to do that in coming years. Before I stop, I just want to point out to a couple different tools, especially for the younger audience in the room, and that I use quite often. Doug Luck talked about climate at a glance, which I use quite a bit. And so one of the tools I want to mention is the climatetoolbox.org. If you want to look at some of the stuff I presented today in terms of recent climate trends in your regions, you can look at, just point location to your county, to a watershed. You can use many of these tools in there, which talks about both the recent observation and future projections and scenarios. So that's a pretty good tool, and I highly recommend. And this is another tool that we have developed in collaboration with our partner at Western Water Assessment, which is the climate dashboard, which tells you about current conditions, current climate conditions, and conditions associated with water availability. So it has conditions on temperature, precipitation, drought, water in reservoirs, streams, etc. So again, a very good tool. So if you just type Rocky Mountain High Plains Climate Dashboard in Google, it should lead you there. And I think that's all I have. And I'll be happy to answer any questions. And thank you for listening.
Thank you. You mentioned that the projected increase in the plains was going to be 5 to 6 degrees Fahrenheit. I'm never so good at transferring Fahrenheit to centigrade or vice versa, but that seems to be higher considerably than the goal of the Paris Agreement, which was to hold temperature increase to 1.5 degrees centigrade and no more than 2. And of course, as you know, the IPCC, the international body of scientists dealing with projections on climate change, project that at even above 1.5, let alone 2 degrees increase, that the impact on ecosystems and the lifeways of indigenous peoples and our food systems would be devastating. And of course, those increases are higher in the Arctic. So, can you comment on that, please? Thank you.
Yeah, thank you. That's a great question. I'm glad you asked it because um, what the IPCC is talking about is global temperature change. And so 1.5 degrees Celsius and 2 degrees Celsius, that's two different markers. and the big aspiration is to keep it under 1.5, and that'll be very challenging. Um, Also, about converting Fahrenheit to Celsius is easy in terms of change. You just divide it by two, just half it. So when I say 5 to 6 degrees Fahrenheit at regional scale, it'd be close to 2.5 to 3 degrees Fahrenheit. But you make a good point that the change at the regional scale of even close to 2.5 to 3 degrees Celsius is more than what IPCC is saying for the global. Um, uh, so so that's the difference between the global and the regional. That even if we keep uh, temperature close to 1.5 Celsius or 2 degrees Celsius warming globally, we will still see more than that temperature increases regionally across parts of the world. Like Arctic is already warmed up more than 2 degrees Celsius. Many parts of the US have warmed more than 2 degrees Celsius. So regionally, you may actually see more warming than 2 degrees Celsius. Um, and that's pretty clear coming out of our models too. So the regional and the global are different. And so something like a 2 to 3 degrees Celsius warming across much of the country is really expected um, through these projections. And in many places, we've already crossed it, as I said.
Thank you, MTRs. Any other questions? We'll have one more time for one more question. Yes, sir. Just use your microphone and identify yourself and your organization, please.
Hello, my name is Christopher Curl. I'm just a local guy. And I was wondering, I seen on the projections on some of the graphs that was medium emissions. Is that like all across the board that these projections were drawn out?
Yeah, a great question again. And the medium emission is taking, when you talk about these medium emissions, there's nothing good about medium emissions. There's high confidence that we may follow these medium emission trajectory, but that leads us to a world that's warmer than 2 degrees Celsius end of the century. So anywhere close to 2.5 to 3 degrees Celsius warming. But yeah, by mid-century, as I said, it's not much of a difference between are we following a high emission or medium emission trajectory? We are still kind of feels like we are logged in to hit 5 to 6 degrees Fahrenheit warming at this point, and almost unavoidable. But yeah, to your point, it's all for medium emission scenarios. And if you do high emissions, the numbers are slightly greater by mid-century, and they are much greater by late century.
Well, thank you, MTRs. And again, thank you for your presentation. It was very informative. And again, we appreciate your time with us today. And we're looking forward to for you and the North Central Climate Adaptation Science Center working more closely with the Oceti Sakowin tribes. So thank you, MTRs. And at this time, we're going to take a 10-minute break. I know I saw Claude Prue dozing off. But let's take 10 minutes and we'll come back with Laura Edwards, our next presenter. 10 minutes.